seawater on LA fires is an experiment scientists are closely watching, according to Patrick McGonigal from The Conversation. Well, that happens in a lot of countries, especially in the Mediterranean. They do use seawater. Firefighters battling deadly wildfires that raced through Los Angeles area January 2025 have been hampered by a limited supply of fresh water. So where the winds are calm enough, skilled pilots flying planes, aptly named super scoopers, are skimming off 1,500 gallons of seawater at a time, dumping it with high precision on the fires. And using seawater to fight fires can sound like a simple solution. The Pacific Ocean has a seemingly endless supply of water. The emergencies like Southern California is facing is often the only quick solution, though the operation could be risky amid ocean swells. But seawater also has its downsides. Salt water corrodes firefighting equipment and may harm ecosystems, especially those like chaparral shrublands around Los Angeles that are not normally exposed to seawater. Gardeners know that small amounts of salt added, say, as fertilizer does not harm plants, but excessive salts can stress and kill plants. And while the consequences of adding seawater to ecosystems are not yet well understood, we can gain insights on what to expect by considering the effects of sea level rise. A seawater experiment in a coastal forest. As an ecosystem ecologist at the Smithsonian Environmental Research Center, I lead a novel experiment called Tempest, which was designed to understand how and why, historically, salt-free coastal forests react to their first exposures to salty water. Sea level rise has increased by an average of about 8 inches globally over the past century, and that water has pushed salty water into U.S. forests, farms, and neighborhoods that had previously known only fresh water. As the rate of sea level rise accelerates, storms push seawater even farther onto the dry land, eventually killing trees and creating ghost forests, a result of climate change that's widespread in the U.S. and globally. In our Tempest test plots, we pump salty water from the nearby Chesapeake Bay into tanks, then sprinkle it onto the forest soil surface fast enough to saturate the soil for about 10 hours at a time. This simulates a surge of salty water during a big storm. Our coastal forests showed little effect from the first 10-hour exposure to salty water in June 2022 and grew normally for the rest of the year. We increased exposure to 20 hours in June 2023, and the forest still appeared mostly unfazed, although the tulip poplar trees were drawing water from the soil more slowly, which may be an early warning signal. Things changed after a 30-hour exposure in June 2024. The leaves of tulip poplars in the forest started to brown in mid-August, several weeks earlier than normal. By mid-September, the forest canopy was bare as if winter had set in. These changes did not occur in a nearby plot where we treated the same way, but with fresh water rather than seawater. The initial resilience of our forest can be explained in part by the relatively low amount of salt in the water in this estuary, where water from freshwater rivers and the salty ocean mix. Rain that fell after the experiments in 2022 and 23 washed soil salts out of the soil, but a major drought followed the 2024 experiment, so salts lingered in the soil then. The trees' longer exposure to salty soils after our 2024 experiment may have exceeded their ability to tolerate these conditions. Seawater being dumped on the Southern California fires is full strength, salty ocean water, and conditions there have been very dry, particularly compared with our East Coast forest plot. Change is evident in the ground. Our research group is still trying to understand all the factors that limit the forest's tolerance to salty water and how our results apply to other ecosystems such as those in the Los Angeles area. Tree leaves turning from green to brown well before fall was a surprise, but there were other surprises hidden in the soil below our feet. Rainwater percolating through the soil is normally clear, but about a month after the first and only 10-hour exposure to salty water in 2022, the soil turned brown and stayed that way for 2 years. The brown color comes from carbon-based compounds leaching from dead plants materials, and is process similar to making tea. Our lab experiment suggests that salt was causing clay and other particles to disperse and move about in the soil. Such changes in soil chemistry and structure can persist for many years. Sea level rise is increasing coastal exposure. While ocean water can help fight fires, there are reasons fire officials prefer freshwater sources, providing fresh water is available. U.S. coastlines, meanwhile, are facing more extensive and frequent saltwater exposure as rising global temperatures accelerate sea level rise that drowns forests, fields, and farms with unknown risks for coastal landscapes. This is from the conversation here under Creative Commons by Patrick McGonigal, Associate Director of Research, Smithsonian Environmental Research Center, Smithsonian Institute on Science Alert. Please leave your comments and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.